So now let's look at a somewhat more interesting example, which is Heap Scan. This would go at the leaf of a query plan. It has no children. When it's called for initialization, it's passed the name of a relation, and it'll look in the catalog to figure out which heap file is associated with this relation, and it'll set up a local variable heap that will be associated with an open file handle for this relation. So heap equals opening the heap file for this relation. And then it's going to initialize essentially a cursor in the relation. It's going to have a current page, which is heap.firstPage, and a current slot on that page, which is the first slot on that page. And then it's going to return because it's ready to go. When the parent calls next on the heap scan, it works like this. If the current page is null, well, that means we're at the end of file and we return EOF, end of fun. Otherwise, we set the current to be pair cur page cur slot. That's a record ID, a page ID, and a slot ID. Okay, so we're going to save that in current, and that's what we're going to return. But we need to move our cursor forward for our next call. And so we'll advance the slot. We're going to say the cur slot equals cur page.next. And the page interface is going to go ahead and give us the next slot on that page that we haven't looked at yet. Now, if there are no more slots on that page, if we've seen all of them already, then we need to advance to the next page. So we'll say cur page equals cur page.next. And then we've got a new page, and assuming that page is not null, we'll take the first slot on that page as the next slot to look at. So at this point, we're ready to return our current tuple because our cur page and cur slot are ready for our next call. And then the close method on HeapScan simply deallocates any operating system's resources associated with that heap file by saying heap.close. All right, note that the HeapScan doesn't recursively call anything for init or next because it doesn't have any children. It does call next on the disk and file manager when it does cur page.next, but it doesn't have any actual iterators below it. Now let's look at a more involved operator, sort. And we'll only look at a 2-pass example here in our pseudocode, but you can imagine the extension to multiple passes. It's fairly natural. We'll start with the init call, which is past the keys that we want to sort by, the columns of the sort key. And the init call is going to implement all of pass 0 of our sorting algorithm. And that's going to make it a blocking call because it's going to consume its entire input before returning. Let's see how it goes. First, it's going to recursively call init on its child to get the child ready to produce tuples. And then it's going to repeatedly call child.next and get tuples to fill up B buffers of memory, which it'll then quicksort and write to a run on disk. And then it'll do it again, continuing to call child.next, filling up B buffers, sorting, and writing to a run on disk until it's consumed the entire input, at which point it's got some number of buffers in memory, it sorts them, writes them to the final run on disk. After having written all the runs to disk, it's going to set up for pass 1 of sort by reading one page from each sorted run file that it generated and loading them into an input buffer. And so at the end of the init call, pass 1 of sorting is ready to go. The minimum tuple to be output is already in memory, and it's ready to be sent to the output. The next call then is going to start pulling tuples through the merge phase of sorting, through pass 1. And we're assuming here in this pseudocode that we have enough buffers to merge and we don't need more passes. So here's how it works. We're going to start by saying the current output tuple is going to be the minimum tuple that's in all of the current buffers. Now, if that minimum tuple is the last one in its buffer, then as a matter of streaming, we want to fetch the next page from that run into the buffer to replace the page that was there. And then we're going to return that output tuple, which was the minimum across all the buffers, and that's the answer to next. Now, if there were no tuples in memory, we would return an EOF, right? And so next keeps getting called like that, returning the minimum tuple so far. Eventually it returns EOF, and the caller will call close. Close will deallocate the run files and call close recursively on the child. So that's how 2-pass sorting works in an iterator fashion.